Our first stop is Kepler 186f, an exoplanet that has captured the attention of scientists and space enthusiasts alike. This planet is located in the habitable zone of its star, Kepler 186, which means it could potentially support liquid water on its surface. Discovered by the Kepler Space Telescope, Kepler 186f is roughly the same size as Earth, making it one of the most Earth-like exoplanets found so far. However, the atmosphere of Kepler 186f remains a mystery. Scientists are still working to understand whether this distant world has an atmosphere thick enough to maintain liquid water. Despite this uncertainty, the discovery of Kepler 186f marks a significant milestone in our quest to find habitable worlds beyond our solar system. The story of Kepler 186f begins with the Kepler Space Telescope, a remarkable piece of technology designed to search for exoplanets by monitoring the brightness of stars. Launched in 2009, Kepler's mission was to find Earth-sized planets orbiting other stars in the habitable zone, where conditions might be right for liquid water to exist. The telescope did this by using a technique called the transit method. When a planet passes in front of its star, it causes a slight dimming of the star's light. By measuring these tiny dips in brightness, scientists can infer the presence of a planet and gather information about its size and orbit. Kepler 186f was discovered using this method. Located about 500 light-years away in the constellation Cygnus, this planet orbits a red dwarf star, which is cooler and smaller than our Sun. The discovery of Kepler 186f was significant because it was the first Earth-sized planet found in the habitable zone of another star. This zone, often referred to as the Goldilocks zone, is the region around a star where conditions are neither too hot nor too cold, allowing liquid water to potentially exist on the planet's surface. The planet's size and location in the habitable zone made it an exciting find. Kepler 186f is about 10% larger than Earth, which suggests it could have a similar composition. However, the exact nature of its atmosphere remains unknown. If Kepler 186f has a thick atmosphere, it could potentially maintain liquid water on its surface. This would make it one of the most promising candidates for habitability outside our solar system. However, if its atmosphere is thin or non-existent, the planet's surface could be barren and inhospitable. Scientists are eager to learn more about Kepler 186f's atmosphere and surface conditions. One way they hope to do this is through the study of the planet's light spectrum. When a planet passes in front of its star, some of the star's light filters through the planet's atmosphere. By analyzing this light, scientists can identify the chemical composition of the atmosphere and look for signs of water vapor, oxygen, methane, and other molecules that could indicate the presence of life. This technique, known as spectroscopy, is a powerful tool for studying distant planets. The discovery of Kepler 186f has opened up new possibilities for the search for life beyond Earth. It has shown that Earth-sized planets in the habitable zone are not unique to our solar system and that there could be many more such worlds out there. Future missions, such as the James Webb Space Telescope, are expected to provide even more detailed observations of exoplanets like Kepler 186f, helping us to understand their atmospheres and potential habitability better. Next, we journey to Proxima Centauri b, the closest known exoplanet to Earth. Orbiting the red dwarf star Proxima Centauri, this planet is just 4.24 light-years away. Proxima Centauri b lies within its star's habitable zone, where conditions might be right for liquid water to exist. This proximity makes Proxima Centauri b a prime candidate for future interstellar missions and the search for extraterrestrial life. The planet's size and temperature suggest it could have an Earth-like environment, but its star emits powerful solar flares that could strip away its atmosphere and harm any potential life forms. The ongoing research on Proxima Centauri b continues to intrigue scientists as they study its potential to harbor life. Proxima Centauri b was discovered in 2016 by a team of astronomers using the radial velocity method. This technique involves measuring the tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. By analyzing the star's light spectrum, scientists can detect these wobbles and infer the presence of a planet. The discovery of Proxima Centauri b was a landmark achievement because it is the closest exoplanet to our solar system, located just 4.24 light-years away. Proxima Centauri b orbits its star, Proxima Centauri, at a distance of about 7.5 million kilometers, which is much closer than Mercury's orbit around the Sun. Despite this close proximity, Proxima Centauri b is located in the habitable zone because its star is a red dwarf, which is much cooler and less luminous than our Sun. This means that the planet receives just enough energy to potentially support liquid water on its surface. The planet's size and mass suggest it could be rocky, like Earth, and its temperature could allow for liquid water. However, the conditions on Proxima Centauri b are far from ideal. Proxima Centauri is an active star that emits powerful solar flares, which could strip away the planet's atmosphere and expose its surface to harmful radiation. This makes the habitability of Proxima Centauri b uncertain. Nonetheless, the planet remains a prime target for future observations and missions because of its proximity. One of the most exciting aspects of Proxima Centauri b is the possibility of sending a probe to study it up close. The Breakthrough Starshot initiative, announced in 2016, aims to develop tiny, light-powered spacecraft that could travel to Proxima Centauri b in just over 20 years. These spacecraft would be equipped with cameras and scientific instruments to study the planet's surface and atmosphere, providing unprecedented insights into this nearby world. Our journey continues to TRAPPIST-1e, one of the 7 Earth-sized planets orbiting the ultra-cool dwarf star TRAPPIST-1. Discovered in 2017, TRAPPIST-1e is located within the habitable zone, where liquid water could potentially exist. What makes this system even more fascinating is the close proximity of its planets to each other. Standing on TRAPPIST-1e, you could see other planets in the system as large as the Moon appears in our sky. TRAPPIST-1e has a rocky composition similar to Earth, and its density suggests it could have a substantial atmosphere. Scientists believe this planet could have the right conditions for life, but its actual habitability depends on factors like atmospheric composition and surface conditions. The TRAPPIST-1 system offers a unique opportunity to study multiple potentially habitable planets in one go, making it a focal point for future observations. The discovery of the TRAPPIST-1 system was a groundbreaking achievement in the search for exoplanets. Using the TRAPPIST located in Chile, astronomers identified the first 3 planets in this system in 2015. Follow-up observations with the Spitzer Space Telescope revealed 4 more planets, bringing the total to 7. All 7 planets are Earth-sized and orbit very close to their ultra-cool dwarf star, TRAPPIST-1. The planets in the TRAPPIST-1 system are so close to each other that they would appear prominently in each other's skies. This proximity means that if you were standing on TRAPPIST-1e, you could see neighboring planets as large or even larger than the Moon appears from Earth. This unique arrangement offers an unparalleled opportunity to study multiple potentially habitable worlds in one compact system. TRAPPIST-1e, one of the 3 planets located in the habitable zone, is particularly interesting because of its Earth-like properties. It has a rocky composition and a density similar to Earth, which suggests it could have a solid surface. The planet's location in the habitable zone means it could have liquid water, a key ingredient for life as we know it. However, the actual habitability of TRAPPIST-1e depends on various factors, including its atmospheric composition, surface conditions, and the amount of radiation it receives from its star. The TRAPPIST-1 system's ultra-cool dwarf star emits less radiation than our Sun, which means the planets receive less energy. This could affect the planet's climates and atmospheres in ways that are not yet fully understood. Scientists are using advanced telescopes and instruments to study the light passing through the planet's atmospheres during transits. By analyzing this light, they can identify the chemical composition of the atmospheres and look for signs of water vapor, oxygen, and other molecules that could indicate habitability. Moving on, we explore Kepler 452b, often referred to as Earth's cousin. Kepler 452b orbits a star similar to our Sun but is about 1.5 billion years older. This exoplanet is located in the habitable zone of its star, Kepler 452, and is approximately 60% larger in diameter than Earth. The extended time Kepler 452b has spent in its star's habitable zone suggests it could have had a long period for life to potentially develop. However, the increased size and age mean it might have a thicker atmosphere and a stronger greenhouse effect, making its surface conditions quite different from Earth. The discovery of Kepler 452b helps us understand how planetary environments evolve over billions of years and what conditions might support life long-term. Kepler 452b was discovered by NASA's Kepler Space Telescope using the transit method. This planet orbits its host star, Kepler 452, every 385 days, which is very similar to Earth's 365-day orbit around the Sun. The star itself is a G-type star, like our Sun, but it is about 1.5 billion years older. This additional age means that Kepler 452b's star has had more time to evolve, and any potential biosphere on Kepler 452b would have experienced different conditions compared to Earth. One of the key factors that make Kepler 452b an exciting discovery is its potential for long-term habitability. Given its position in the habitable zone and its Earth-like size, it is conceivable that Kepler 452b could have maintained liquid water on its surface for billions of years. This long duration in the habitable zone provides a stable environment where life, if it ever arose, could have had ample time to develop and evolve. However, there are also significant challenges that Kepler 452b might face in maintaining habitability. One major concern is the greenhouse effect. Due to its larger size, Kepler 452b likely has a thicker atmosphere compared to Earth. A thicker atmosphere could lead to a stronger greenhouse effect, trapping more heat and potentially making the surface too hot for liquid water. Additionally, as Kepler 452 ages, it grows brighter, increasing the amount of energy the planet receives. This could further enhance the greenhouse effect, potentially leading to conditions similar to Venus. Understanding Kepler 452b's atmosphere is crucial for determining its habitability. Scientists hope to use advanced telescopes, like the James Webb Space Telescope, to study the planet's atmosphere in detail. By analyzing the light spectrum from Kepler 452b during transits, researchers can identify the chemical composition of its atmosphere and assess the presence of gases like carbon dioxide, water vapor, and methane. These observations will provide critical insights into the planet's climate and potential habitability. The discovery of Kepler 452b also highlights the importance of studying older planetary systems. As stars age, they go through various changes that can significantly impact the planets orbiting them. By studying planets around older stars, scientists can gain a better understanding of how planetary environments change over time and what conditions might support life for extended periods. Kepler 452b serves as a valuable case study for these investigations, offering a glimpse into the long-term evolution of habitable worlds. Finally, we arrive at HD 209458b, also known as Osiris. This exoplanet made history as the first planet observed transiting its star, allowing scientists to study its atmosphere in detail. Located 150 light-years away in the constellation Pegasus, HD 209458b is a gas giant similar in size to Jupiter but orbits much closer to its star, making it a hot Jupiter. The study of its atmosphere revealed the presence of water vapor, carbon dioxide, and methane, marking a significant breakthrough in exoplanet research. The atmospheric data from HD 209458b provided valuable insights into the composition and behavior of exoplanet atmospheres, paving the way for future studies of other distant worlds. HD 209458b, or Osiris, was discovered in 1999 using the radial velocity method, but it gained significant attention when it became the first exoplanet observed transiting its host star. This transit provided a unique opportunity to study the planet's atmosphere, as some of the star's light filters through the planet's atmosphere during the transit. By analyzing the spectrum of this filtered light, scientists can identify the chemical composition of the atmosphere and gain insights into the planet's characteristics. One of the most remarkable findings from the study of HD 209458b was the detection of water vapor, carbon dioxide, and methane in its atmosphere. These discoveries were groundbreaking because they demonstrated that it is possible to study the atmospheres of distant exoplanets and identify specific molecules. The presence of these molecules also suggested that HD 209458b has a complex atmosphere with dynamic processes, similar to those found on gas giants in our solar system. HD 209458b's close proximity to its star classifies it as a hot Jupiter, a type of gas giant that orbits very close to its host star, resulting in extremely high surface temperatures. The intense heat from the star causes the planet's atmosphere to expand and escape into space, a process known as atmospheric evaporation. Observations of HD 209458b have shown that it is losing its atmosphere at a significant rate, creating a tail of escaping gas similar to a comet. This phenomenon provides valuable insights into the atmospheric dynamics of hot Jupiters and helps scientists understand how these planets evolve over time. The study of HD 209458b has also provided important lessons for the detection and characterization of other exoplanets. The techniques developed to study its atmosphere have been applied to many other exoplanets, leading to the discovery of diverse atmospheric compositions and properties. These findings have expanded our knowledge of planetary atmospheres and have highlighted the variety of conditions that exist in planetary systems beyond our own. The discoveries of these 5 exoplanets, Kepler 186f, Proxima Centauri b, TRAPPIST 1e, Kepler 452b, and HD 209458b, represent significant milestones in our quest to understand the universe. Each of these planets offers unique insights into the conditions that might support life and the processes that shape planetary environments. As we continue to explore the cosmos, we are likely to uncover many more fascinating worlds that challenge our understanding of what it means to be habitable. The search for exoplanets has come a long way since the first discovery in the 1990s. Advances in technology and observational techniques have enabled scientists to detect thousands of exoplanets, ranging from Earth-sized rocky worlds to massive gas giants. These discoveries have revolutionized our understanding of planetary systems and have revealed that planets are common throughout the galaxy. One of the most exciting aspects of exoplanet research is the potential to find signs of life beyond Earth. While we have yet to discover definitive evidence of extraterrestrial life, the discovery of habitable zone exoplanets like Kepler 186f and Proxima Centauri b raises the possibility that life could exist elsewhere in the universe. Future missions and telescopes, such as the James Webb Space Telescope and the European Space Agency's Plato mission, are expected to provide even more detailed observations of exoplanets, bringing us closer to answering the age-old question of whether we are alone in the universe. In addition to searching for habitable worlds, scientists are also studying the diversity of exoplanetary systems to understand how planets form and evolve. The variety of exoplanets discovered so far, from hot Jupiters to super-Earths, suggests that planetary systems can take many different forms. By studying these diverse systems, scientists can gain insights into the processes that govern planet formation and the factors that influence a planet's potential to support life. The study of exoplanets is a multidisciplinary field that brings together astronomers, astrophysicists, chemists, biologists, and planetary scientists. This collaborative approach is essential for understanding the complex interactions between a planet's atmosphere, surface, and potential biosphere. As new discoveries are made, the field of exoplanet research continues to evolve, pushing the boundaries of our knowledge and challenging our perceptions of the universe. These 5 exoplanets, Kepler 186f, Proxima Centauri b, TRAPPIST 1e, Kepler 452b, and HD 209458b, represent just a small fraction of the incredible diversity of worlds that exist beyond our solar system. Each discovery brings us closer to understanding the nature of planets and the potential for life in the cosmos. As we continue to explore the universe, we are likely to find even more extraordinary worlds that will reshape our understanding of what it means to be habitable. Thank you for joining us on this cosmic adventure. The discoveries of these exoplanets have opened up new frontiers in our quest to understand the universe and our place within it. Stay tuned for more exciting discoveries in the world of space science. Until next time, keep looking up and wondering about the endless possibilities that lie beyond our home planet.